Wow.
Thank you. Okay, so welcome to everybody. This is such an exciting one, and I mean, I could spend an hour talking about Professor James and the all of his awards and his wonderful life, but he certainly is a very high-profile speaker. So we're delighted that you're joining us here today and sharing your knowledge with us. I'll just quickly run through. He's um, he's a scientist, a researcher, a humanitarian, and he's led significant research programs in agricultural biotechnology. Now, just looking at I just have to drop some of these awards. He became an officer of the Order of Australia in 2004. He was a Queensland Greats Award winner in 2015. He was the recipient of the Queensland Senior Australian of the Year in 2019, and then he became a Companion of the Order of Australia in the 2022 Australia Day Honours. So he got upgraded for his eminent service to agricultural science. Today, of course, he's going to talk about the future of bananas, the new book that he has just released, and just this fascinating story about how I mean, it reminds you a little bit of the Irish, with their reliance on that one potato variety. And we all around the world now are relying so much on the Cavendish banana. And James has been working to try and sort of future-proof the Cavendish banana. And of course, he's got a lot of other things to tell us about. So thank you very much, James, for enjoying us. And please make him welcome, everyone.
Good morning.
Welcome.
Well, thank you, and thank you, Judy, for that introduction. Yeah, it's a new era for me because I retired from QUT about 2 weeks ago. Not that I'm going to come out of stop working on bananas. That's not true. I'm just going to do it under a different title. Anyway, today I'm going to talk about the future of bananas and I had a book published last week, which I can talk a little bit about right at the end. So I wanted to get across the idea that bananas are probably the ancient fruits of the forest. But I'll give you a little. I'm not sure how much everybody knows about banana biotechnology. So this is Bananas 101. This is a schematic of a banana. It is a giant herb. It doesn't have a stem. It has a pseudostem, which is made up of the petioles of the leaves. Down the bottom, a corm, which has a whole lot of different growing points, one of which produces that first plant. And when the plant has generated enough energy in that corm, the growing point goes straight up through the top of the pseudostem and pops out with a bunch. And when that bunch is mature and cut down, then that stem dies. And in nature, a sucker from the side grows away from that. So in ancient times, they were propagated naturally from seed and suckers, but that has changed. Okay, so where'd they come from? Most people think they came from South America. No, they're from our region, right from sort of the Southeast Asia, right across through Asia. Two major varieties or species, Musa balbisiana and Musa acuminata. And Musa acuminata occurs with around about 5 or 6 different subspecies, which were very much genetically or geographically isolated and had evolved their own particular characteristics. So what happened when the humans first wandered across from Africa? They started moving these subspecies around. So the subspecies were diploids, just like we're diploids, they were diploids, and they were fertile, and the fruits were absolutely stuffed full of seed. And I'm not sure whether any of you have actually tried to eat a banana seed, but it's a bit like eating a pebble. So these fruit were absolutely stuffed full of seeds. And so probably the early people in that region may have been eating the banana flowers, they still do. It was probable they were using the leaves for shelter and maybe getting a little bit of flesh out of the fruits. But as they started to move those subspecies around, those subspecies started to interbreed naturally, And we started to get these hybrids, and the hybrids, most of them, or many of them, were triploids. And once you got a triploid, so they had 3 copies of each chromosome, they became essentially sterile. And that's when the bananas that we know now, domesticated bananas, really started to develop. And they developed obviously over quite a long period of time. So the bananas that we eat today, the vast majority of them, there's 1 or 2 that have been bred, but the vast majority have never been bred. These are what wild bananas look like. So the fruit is absolutely stuffed full of seed. And on the right-hand side there, I've got not a very good photo of a wild banana. They look pretty much the same as the ones we grow today, but they have fruit full of seed. So where they came from, they started off in Southeast Asia, across to South Asia, and then over about 5,000 years, they started to move. So firstly, they moved across to Africa, and we believe most of that movement was through Arab traders trading between India and going all the way down into Africa. And bananas have become a major crop in Africa, particularly a subsistence crop, and a very important staple crop, a survival crop. And then finally went the wrong way. Then finally over to Central and South America and the Caribbean. So that was their last port of call. So over that 5,000 years, they've really become ubiquitous in the wet tropics and subtropics. So I always say whenever you see a library film or on the news of a bit of agriculture or in the tropics or subtropics, look in the background, you'll normally always see some bananas growing. So they became incredibly important food for domestic diets in the tropics, both as dessert fruit, so eaten raw, but also cooked, and I'll go into a little bit of that bit later. So when we think about the pre-1850s, and I'll particularly concentrate on this South and Central America area, bananas were grown primarily by smallholders, particularly in the Caribbean. We believe that many of them came over during the slave trade. People brought their suckers with them. These were pretty small plantations. The markets were primarily local markets. And during those pre-1950s, 1850s, not 1950s, 1850s, there were some pretty brave entrepreneurs that tried exporting bananas, particularly out of the Caribbean. Most of those failed, primarily because once you cut down a banana, within 3 weeks they're past ripe, and the ships were sailing ships, and so unless everything worked perfectly well, then the crop had already spoiled before it got particularly to North America. That changed around about the 1850s, and there were 2 really big changes. The first one was steamships. So suddenly we could move goods around much more quickly than by sailing ships. And the other one was finding a banana which was ultimately called Gros Michel. And I always get pulled up by people saying, oh, no, that must be Gros Michel. Now, all of the South Americans call it Gros Michel. Now, the thing about this banana was it was very high yielding and it was an incredibly tough banana. Most of the others that were grown in the region were not like that. And all of the local farmers realised, particularly this is around Jamaica, those sorts of regions, that this was a fabulous banana, and it became widely grown in the Caribbean. Then the entrepreneurs started to export bananas to Europe. To North America primarily initially. And then they realised this banana grew brilliantly well over in South America and Central America, and that's when we started to get these huge banana plantations. And very soon after that, the export to primarily Europe started. So the export market had started. I could spend the rest of the talk talking about the banana wars and the banana republics. It's a fascinating and pretty grim history when you read about it, and particularly all of the interventions from the CIA, etc. So, but I won't do that because it'll get away with much more important things that I want to talk about. So from the 1850s to the 1950s, Gros Michel was the banana. It was the most popular banana, and it was tough. They didn't. They used to harvest the bunches. They didn't cut the hands off the bunches. The bunches were carted around on trucks or on wagons and just literally thrown into ships. That's how tough it was. So it totally dominated that export market and was starting to move around the world. However, things started to change and from about 1890 onwards. And in 1890, Panama disease race 1 was first recorded in Gros Michel. Interestingly, it's called Panama disease. If we go back to the 1890s, there was a guy called Bancroft who lived in Brisbane, who was a medical doctor, but he was also a very keen biologist. And our bananas, apparently, particularly ladyfinger bananas up in around Brisbane, were dying. And he probably identified Panama disease race 1 for the first time. So this is a soil-borne fungus that had been carted around, of course, from where bananas eventuated. However, 2 American guys wrote more important papers, shall we say, on the discovery of this disease. And so rather than it being called Queensland disease or Brisbane disease, it ended up being called Panama disease. I don't think anyone in Queensland's too worried about that. So Panama disease, it's a soil-borne fungus. It's moved around on plants, on implements, and it infects the roots and grows up and kills the banana. And it kills them fairly quickly. So 6 to 8 weeks after infection, the banana will die. And once it's in the soil, you can't get rid of it. It's there forever. So by the 1950s, the Gros Michel industry had collapsed, and there was a replacement straight off the shelf, if you like, called Cavendish, because Cavendish is resistant to Panama race 1. So that's how Cavendish started, and it's virtually accounts for virtually all the export bananas in the world today, and they're worth around about $20 billion a year. So it's a pretty big market. So that was a complete replacement from 1850 very quickly over to Cavendish. So where are we now in the 21st century? Bananas have become one of the top 10 world food crops. It's by far the biggest and most important fruit crop. About a third of them are produced in Africa, Asia Pacific and the Americas. Only about 15% of them are exported. The vast majority, 85%, are consumed and traded locally. And we keep forgetting about that. And the big areas of consumption are the African Great Lakes region, particularly places like Uganda, Rwanda, Burundi, and to a lesser extent Kenya and Tanzania. And also in Papua New Guinea. And Papua New Guinea is just a fabulous area for bananas because it's one of the key centres of origin. So bananas rate about number 7. If you look at that, if you look at those top 10 food crops, all except for soybeans are energy crops. They're starch crops, and that's obviously why they're by far the biggest. And worldwide, India is by far the largest producer, followed by China and followed by Uganda, because Uganda, bananas are their staple food. So even though they only have, I don't know, 30 odd million people, or 40 odd million people, they nearly produce as many bananas as China. None of those countries export. Philippines, Ecuador, Colombia, Cameroon are big exporters. Ecuador is by far the biggest, even though it doesn't produce as many bananas, it exports most of them. And that actually becomes important in a very short period. However, we talk about Cavendish. The diversity of bananas is just incredible. I would like to say that this photograph is we just happened upon it. No, it was set up. But you do see incredible diversity, particularly in Asia, and sizes, shapes, flavors. Yeah, just fabulous. But we're totally dominated by Cavendish. So I've just put up some of these, and we think it's around. There's more than 1,000 different varieties and land races. So of the dessert bananas, we're a Cavendish, Ladyfinger, Gros Michel, etc. And then we've got a whole lot of cooking bananas, and they include the plantains, but also the East African Highland bananas. And then we've got a couple of others which are interesting. There are beer bananas, and in particularly in East Africa, producing beer from bananas is a favourite pastime. And I've done a lot of work in Uganda, and whenever you go to a plantation, they always want to give you their local brew, and they're always very proud of it. I don't think it's going to take off as a major beer in Australia. It's pretty ordinary. You'd have to be pretty desperate, but they seem to love it. But there's a species of banana called Musa textalis, which is grown primarily in the Philippines and has the most incredible long fibers, and it's used for making rope, and it's incredibly strong. So let's go on to Cavendish. So Cavendish is it's a naturally occurring hybrid. So I'm assuming that most of you will have eaten a Cavendish banana. So next time you eat a Cavendish banana, think about the first early farmer who plucked that one banana off a bunch of bananas, probably on the edge of a forest somewhere, more than 1,000 years ago, and it's exactly the same banana. It's hardly changed at all. The flavour would be the same, and that's because these are vegetatively propagated. Once they lost the ability to produce seed and only grown from suckers, so every Cavendish banana is essentially the same. Doesn't matter whether it's grown in South America or it's grown in far north Queensland or it's grown in China. And we believe Cavendish probably came from southern China. Some people say Vietnam. No, it's most likely southern China. And the reason it's so popular is that number one, it's resistant to Panama disease race 1, but it does have very big bunches and it has very thick skin, so it travels well. So those are the sorts of characteristics that have allowed Cavendish bananas to now represent nearly 50% of the bananas grown in the world. So if you think about just having a monoculture of one genotype, this is probably the most extreme example of any crop. 50% of the bananas, one single genotype, and obviously putting it under huge pressure, and that just is getting worse and worse. So a little bit of history. There was a guy in Mauritius, a religious pastor who was an avid collector of plants, and there were a lot of Chinese coming through Mauritius on the way to Africa, etc., probably not of their own free will. And this guy was collecting plants, and he was particularly interested in the bananas they collected. And he collected these two suckers from because the Chinese were bringing their plants with them. And he collected these two suckers, and he contacted one of his colleagues or friends in England. And I said, said in a letter he's got these two wonderful bananas that he's found, and he sent this guy, his name was Barclay, sent him two suckers, and that was in 1829. So Barclay, an intrepid collector of plants, was growing these bananas. Unfortunately, never saw them fruit. He died, and his descendants decided they didn't want to keep all these plants, including the bananas, and they sold them. One was sold to a nursery, and the other one was sent to Chatsworth House in the north of England, in Derbyshire. And I went to Chatsworth House. This is in 2019. That's what Chatsworth. It's not a house. It's a massive place, and the plant. This one sucker was sent to this guy Joseph Paxton, and Joseph Paxton was a head gardener at Chatsworth House. He was an avid plant collector and a self-trained horticulturalist, and he also built a wonderful glass house at Chatsworth where he kept the bananas. They were heated by steam from burning coal. But he was an amazing guy. He also designed another massive glass house, and that was Crystal Palace in London. So he described this banana that he had, and it's now still kept at Chatsworth House in a locked glass house, and I was lucky enough to go in there and collect some of the leaves, and we've taken back and we've actually sequenced its genome. So he described it, and in one of the British botanical journals, and he called it Cavendish because his employer, who's the Duke of Devonshire but lives in Derbyshire, family name is Cavendish. So that's where it all came from. And there it is. That's the original Cavendish still in there, that's been propagated over all these years, which is fabulous. So from there, Cavendish was taken through the Canary Islands and ended up in South and Central America, and was also sent to the South Pacific by a guy called John Williams, who unfortunately, while he introduced bananas to the natives, or Cavendish for the natives, they took over. They accepted the bananas, didn't accept him. They killed him, which was a bit nasty. We got our Cavendish directly from China. The Chinese, that's Australia. The Chinese brought them down during the gold rush. So that's poor old John Williams being beaten to death in Samoa. So it didn't go so well for him. So there are some problems, unfortunately, as you might guess, with a vegetatively propagated crop that has never been bred, just selections from the wild. So the vast majority of our domestic bananas are sterile, so no seeds. Cavendish, 50% of the world banana production over vast monocultures. And when you see these monocultures, it's incredible. So they've never been genetically improved, but they're plagued by a whole range of diseases as well as fruit quality problems. So this is a wonderful front page of the New Scientist. This is going back a fair while now. So the last days of the bananas, and there you see on the headstone there, killed by plague 2013. Well, they were a little bit out. They're still going pretty strong in 2026, but there is a global crisis. And the global crisis is because of two major diseases. One's called black sigatoka, and it's a aerial-borne fungus. It infects the leaves, and it started to spread from the 1960s. It's called sigatoka. It's actually should be pronounced Singatoga. It comes out of the Singatoga Valley, first found in the Singatoga Valley in Fiji. If it's left uncontrolled, it'll drive the yield down by more than 50%. It's controlled by fungicides now in the big plantations, but they're spraying now more than 50 times a year, and many of them in the worst areas, it's over 75 times a year. So every 3 or 4 days they're spraying, and the environmental impact of this is just dreadful. So the other disease is also a Panama disease, but this is tropical race 4. So again, it is like race 1, it's soil-borne, it moves around very easily in the soil, in water, etc., tools. There's no chemical control. The big problem with tropical race 4 is that it kills Cavendish and virtually all other bananas. And once it's in the soil, you can't get rid of it. So I've put this series of slides together showing the TR4 pandemic. TR4 pandemic. It's not a fast pandemic, it's slow moving. It was first found in Indonesia and Malaysia, and it's probably been there forever. It probably evolved in that region, and that's a region of high biodiversity of bananas. Got into the Northern Territory, so this is between 1960 and 2000. Got into China, got into Taiwan, and into the Darwin region in Australia. We're not sure how it got there. Lots of theories, but we were obviously very close to where it originated. Then it started to spread. It went up to the Philippines, which is a major exporting area in Asia. It is a major exporter in Asia. But then it started to spread across Asia as well, into Middle East and into Africa, got into Mozambique, and that was taken there by workers from the Philippines setting up a plantation in Mozambique. Disaster. Then it's now been found in India, and also, and I got into strife by putting this slide up at a World Trade Organization. It's in UK. Many of you might have been to the UK and been to the Eden project down in Cornwall, where they've set up wonderful glass houses with incredible variety of plants. They imported bananas from somewhere or other, and they imported tropical race 4 as well. So UK is infected with tropical race 4. It's probably not going to devastate their banana production, but still. Then the big one was it got into South America and was first recorded in Colombia. And South and Central America and the Caribbean account for 85% of the export bananas. So Colombia, Peru, and then very recently Venezuela. And virtually all of now Asia is infected. And then last year in October, it hit the big one, it hit Ecuador. So we now expect it will move all the way through the South American crop and up into the Central American crop. A couple of photos. I took this one out of a small plane in Philippines in 2050. You can see that the plantation is now being devastated by TR4. It's slow moving, it doesn't kill everything at the same time, but once they're infected, it causes massive problems. And this is the plantation we work on. It's been in the Northern Territory for a long time. And on the top left-hand side, you'll see the plantation we work on. It's the last commercial plantation of bananas in the Northern Territory. That's a 18-month-old plantation. If you look carefully, there are already holes in it and a lot of yellow plants. They're all due to tropical race 4. It moved into our major production area in the Tully Valley in 2015. Then 2017 moved more into many more plantations. In the Tully Valley now, there are 11 plantations infected. It's just moving from one plantation to the next and will continue to move. So the real thing is how are we going to survive TR4 and black sigatoka? Because we've got to remember both. So once TR4 reaches a region, it spreads is just inevitable. and spraying 50 times a year for Sigatoka is just not sustainable. So we've got to look at mid to long-term solutions, and the most obvious way to control diseases is through resistant varieties. So we now have a whole lot of options for resistance. Up until sort of 40 years ago, I suppose, there were really only two options. That was selecting out tolerant selections or conventional breeding. We now have two other very important technologies that we can use. One is genetic modification, and the other one is called gene editing, and it's more recent. Genetic modification's been, there've been crops commercialised since the mid-1990s. Gene editing, only over the last 3 or 4 years have there been crops, gene-edited crops that have been commercialised. And we can split genetic modification into two. One is called transgenic and the other one's called cisgenic. Quite a big difference. Cis and trans, right? Trans is a cross, cis is the same. So transgenics are when we move DNA or move genes from, in this case, things other than bananas, whereas cisgenics are when we introduce genes from a banana itself. So when we look at conventional breeding, and this is quite important, there are a number of conventional breeding programs going on in bananas now. So we do same old thing. We take a male and a female plant. Neither of those can be Cavendish because Cavendish is sterile. So what we will end up with is a non-Cavendish. If we take, and I should mention, we've sequenced the banana genome. We've done it, a number of other groups have done it. We've done Cavendish, we've done a number of wild bananas. We now know that bananas have around about 25,000 genes. We have about 19,000 genes, so one would suspect that number of genes isn't related to intelligence. But we've got what I call a genetic book of bananas. So it's a catalogue of banana genes. So we now are starting to understand what all those genes do. We're still way behind. We don't have perfect knowledge at all, but we have identified resistance genes in those bananas, and those genes are in our genetic book of bananas. So genetic modification, we can take Cavendish, and we have, and introduce a single resistance gene. So 1 out of 25,000, and we can move that into a banana. And so we can make Cavendish, and we can make it with resistance. And we've done that with a banana called QK4, and I'll talk a little bit about that in a moment. So if it was a cisgenic, we'd move a banana gene. If we took a gene from somewhere else, say a cucumber, it would be transgenic. And then gene editing is the next level. So gene editing, we don't even introduce any new DNA. We actually just manipulate the DNA that's already in the plant. And we've done that at QUT. There are a couple of, there's a company in the UK and almost certainly China is involved in that as well. So making QK4. So that's the world's first genetically modified banana. And what we've done is we've moved a gene we called RGA2 from one of these wild bananas, and was Musa acuminata malacensis, that was found in a Cavendish plantation in Southeast Asia, where it was growing really well, and everything else, all the Cavendish, was dead. So we moved that, and I've just given a schematic here. I won't go through it just for time reasons, but essentially what we do is we take bananas back to just single cells, and then we insert the gene into that single cell, and then from that single cell regenerate a whole banana back. And that's how we do that genetic modification. We actually use a bacterium called Agrobacterium, which is a natural genetic engineer. It's been genetically modifying bananas forever. Oh, not bananas, but other plants forever. And then we took it into the field in 2012, and over a 14-year period, we did field trials up at a place called Lambles Lagoon, up in the Northern Territory, at that plantation I said, which was the last plantation. Challenging little place. You can find crocodiles in the irrigation canals. Every now and then you'll find the odd buffalo wandering through. And just to keep you on your toes, there are a fair few snakes around as well. So when we do a risk assessment for our university, it's actually quite a lengthy document to try to outline all of the potential hazards. But it's been a great place to work, and we've been able to make really good strides. So this is what the banana field trial looks like. It's actually still in the field now. And this one was taken in 2020. So after 3 years or 3.5 years of planting in a field that was heavily infested with the fungus, we took up 4 different bananas. So the controls were Williams and Grand Nain, they're Cavendish types. And here is our QCAV4. So after 3.5 years, Williams had 92% infection, Grand Nain 70%, now QCAV4 had 2%, but even those 2% didn't die. They showed symptoms but never died, which was amazing. And that's what it looks like. There's the control plants on the left-hand side and QCAV4 on the right-hand side. And when we cut that pseudostem open, you get this awful necrotic browning there. That's the damage that the fungus causes. And when we look at QCAV4, absolutely clean. So that's what happens over a period of time. The green line there is the infected normal Cavendish, and down the bottom here is our QCAV4, which hardly gets any infection whatsoever. And most importantly, the yield is the same. So that's been very important. We mapped this over now nearly 8 years, and these plants are still in the field. None of the non-GM plants are surviving. So what we've done is we've actually taken that through our regulatory system in Australia, which is through Food Standards Australia and New Zealand, and the Office of the Gene Technology Regulator, and it has now been released in April 2024. They released our banana for commercial production, and they're now growing in 3 places. One still up in the Northern Territory. We're doing a field trial down in southeast Queensland, but also another field trial up in North Queensland, because the growers want to make sure that it performs as well up there. So this is the first genetically modified banana released in the world. It's the first GM fruit in Australia to be released. So that's terrific. We've got close to immunity. There's no impact on yield. We used a banana gene, so Cavendish will always be available. So that's fantastic. However, we've got a problem, and that is that QCAV4 is genetically modified, and we have a real public perception and consumer acceptance problem. And also with GM, the regulatory environment in Australia is tough. The rest of the world, other than, say, the US, is diabolical and just so expensive, and we would have to apply to every individual country that would either grow or consume QCAV4. However, depending on the country, gene editing and cisgenics are or will not be considered GM. So this means that there will be minimal regulation and they won't be labelled. So that gives the possibility of developing bananas with disease resistance and other things that will not be as heavily regulated as GM. And so we can go here with gene editing or with cisgenics, and we can do it with Cavendish, and we can do it with virtually any other banana variety as well. So we've already got gene edited Cavendish in the field, up in our field trial. On the left-hand side, there is our first planting that's now in its third year, and the second planting is now in its first year. There are some reasonable results, nothing outstanding yet, but it's still very, very early days. Okay, so let me go back to this slide that I love. Absolutely massive genetic diversity. But when we look at all those bananas there, nearly all of them are susceptible to tropical race 4 and black sigatoka. And of course, we've got our little one down there, that's Musa acuminata malacensis. It is resistant to both of those diseases and has been forever. So the potential now is with our genetic book of bananas is that we can order a gene online, literally, we can order a gene online and we could take any one of those varieties and generate resistance to tropical race 4 and race 1. And not yet, but soon, black sigatoka. We've also done elevated provitamin A. It's possible to increase the shelf life. And it's important to be able to shorten the shooter stem. Gros Michel, Big Mike, is called Big Mike because he's so big, so tall. And we can make, in the future, thicker fruit skin. So what that means is instead of just having Cavendish, we can start to have a whole variety of different bananas on in our supermarket and be able to retain all this incredible genetic diversity. So this is a fabulous opportunity, and it's now available to us. So this is the challenge, to start improving and staving the wonderful diversity of bananas, and I'm hoping that we'll be able to do this more and more. And it's not only bananas that we can use these sorts of technologies for. There's another disastrous disease called Halong Bing, or citrus greening, which is starting to move around the world. There is no resistance in any of the commercial citrus, and over a period of time they lose all of their vigor and die. The citrus trees, that's oranges and lemons, etc. Amazingly, there is not so much resistance but tolerance in the Australian wild citrus, the Microcitrus australis, and they're trying to see whether they can breed that into citrus. And there are a whole lot of other diseases as well, and other crops. So we're now getting technologies that we can use to safeguard a lot of our really precious biodiversity and make some of these crops much more commercially viable. And I'm hoping that's going to happen in the next decade or so. So thank you very much. I've done a little ad for my book on the left-hand side there. So it's called Futures of Bananas. It's published by Melville House. It came out last week. So thank you, and I'm happy to answer any questions.
Right. Well, absolutely fantastic. It's just amazing. So, James, how are things now that you've retired? These programs going on?
Oh, yes, luckily, yes.
Yes.
So, needless to say, doing this sort of work isn't a one-person job. It requires big teams, and I've had big teams at QUT. Unfortunately, both myself and my second in charge, a guy called Rob Harding, both retired. He retired before me, dreadful fellow. But we've got young guys coming on that have got the same sorts of skills and dedication. So I expect the program to continue on. It's still got a long way to go, and we're now in that phase of going through with both cisgenics and gene editing.
Right. So any other questions from people?
I have one.
Yep, go ahead.
Thanks, Neville.
I'm from Western Australia. Are these diseases found in Carnarvon, our main growing area?
No, tropical race 4 isn't.
Yep.
I'm pretty sure race 1 is, but
Uh-huh.
Carnarvon, I think Carnarvon, the vast majority of bananas up there are Cavendish.
Yep.
Yeah. So as long as, and I'm just writing a little piece for somebody else. Humans are wonderful at moving diseases around. These diseases don't move by themselves. They need human intervention. And by golly, we're good at it. So I think the classic one is COVID, of course, that went from China around the world in about 12 months.
Yep.
Tropical race 4 takes longer than that. I think as long as there is reasonably good regional quarantine and security up in Carnarvon, they're probably going to be okay.
Yep.
Okay, so we've got a
Very good.
question. Thanks, Neville. A question here from Marianne. She says, "What should home gardeners growing bananas need to do, if anything?" I'm growing Ducasse bananas. Is that how you pronounce it?
Yeah, so Ducasse is a fabulous little banana. I'm glad you're growing. I grow them myself. It's susceptible to race 1 and tropical race 4. The likelihood of tropical race 4 getting into a home garden in the foreseeable future isn't high. In fact, it's probably very low. There is anywhere there is tropical race 4, those plantations are under quarantine. So Australia is trying to limit the movement. They can't stop it, but trying to limit it. So home gardeners for TR4 probably not a great concern. Race 1, yeah, you just have to be careful about bringing in any other bananas because people tend to share their suckers, and stuck on the suckers is all the soil, and stuck in that soil could be race 1.
And there are restrictions in Queensland on moving bananas around, I think, aren't there?
Yeah, oh yes, definitely, yeah. But that's not so much for Panama disease. It's actually for another disease called bunchy top,
Oh,
which occurs in northern New South Wales and southeast Queensland, but doesn't occur in North Queensland. So you're not allowed to move bananas from the south up to the north.
okay, right. So Marianne's given you a thumbs up. She was pleased to find that hers is not under threat so much. So Jackie's question there, was the research trial in Darwin affected by the banana freckle outbreak at all?
Aha, yes. So our back in 2015, they found banana freckle up in the Northern Territory. And so the idea was, let's kill all the bananas in the area and we'll get rid of it. Unfortunately, our field trial was in that area. So our first field trial was destroyed in 2015, and we weren't able to replant until 2018. So our second field trial went in 2018. They didn't eradicate freckle, unfortunately. It's still kicking around. But luckily it doesn't seem to be causing too many problems. There aren't many commercial or large plantings of bananas in the Northern Territory anyway.
Yeah, I was curious why you were doing this trial in the Northern Territory with the crocodiles and the snakes, etc. Most of the distance, was there a particular reason why you chose to do it up there?
The reason was that when we're doing this work, we started in 2012 for the field trials. TR4 didn't occur in Queensland, so it only occurred in the Northern Territory. So we really didn't have an option. But also in Queensland, even though it's now present in Queensland, when the disease occurs, the area is put under quarantine. So we couldn't do field trials there anyway.
Right. Okay. Thank you. Just a question from me again about the when you were saying about the resistance to genetic modification, and you said that each country has to be approached. Is that true of Europe? You have to go to every country in Europe, or do you know if it's
Yeah, Europe's a fun, but you wouldn't get any GM bananas into Europe,
no.
or New Zealand for that matter. They're the two of the most extreme with their GM. Amazingly, most people don't realise that there are GM crops grown in Europe. Spain grows GM maize and Bulgaria grows GM maize, but the vast majority of those countries don't allow GM food to be grown. However, the European Parliament has just passed a new whatever, I don't know what it's called, regulation or bill or whatever, to allow gene editing and cisgenics as non-GM. So that's a huge step forward.
Wow. Well, that's great, isn't it? Otherwise, they'll be without any bananas soon, won't they?
Exactly.
That'd be a great revenge, wouldn't it? So,
Yeah, that's right.
yes.
Yeah. So that's been a big change, and in fact, their regulations go a little bit further than Australia. So they've sort of gone, even further than we have, and I think ours are pretty good.
Wow, that's great. Okay. Any other questions?
Yeah, I've got a question. Can you hear me?
Yep.
Yeah, yeah. So I do food gardens in schools, and one of my schools has got it's almost a botanic garden, but they have got bananas. So I'm in Adelaide. They've got bananas growing. They were planted by someone a number of years ago, but obviously that person's moved on. So no one in the school knows anything about growing bananas and how to look after them. So so just more of a technical thing is like where's the best place for them to find how they should be managing the bananas that they've got?
So the best place to go, so the Australian Banana Growers Council have a very good website.
Yeah.
And that's probably first point of call. And there's lots of resources there. And if they can't help you, they'll certainly put you in touch with whoever can.
Yeah. Because I know that they've got their bananas, and just the way they sort of manage cutting them down or managing even the suckers and how they just sort of like try and contain it. But I think they just probably then removing what is going to produce for them, I think.
Yeah, that's usually the biggest challenge. So and a guy explained to me when we were working over in Africa. So every plant you should have a grandmother, mother, and daughter. So the grandmother's got the bunch. The mother is about halfway up, and the daughter is the sucker at the bottom. Yeah. And you cut off all of the other suckers, because otherwise you just end up with a great big mat of bananas which produces very little. So the idea is you cut down the grandmother, and the mother grows up, and the daughter grows up, and then next generation comes on. And that's how they do it commercially as well. So when somebody explained to me the way they do it, and farmers will essentially make sure that they trim off the suckers so they all go in one direction. Otherwise, you'd end up with a hodgepodge and wouldn't have any laneways paths between the bananas.
Right.
As when someone explained to me, in northern New South Wales, they grow bananas on northeastern slopes because it's a bit cooler, and the plantation actually walks up the hill.
Yeah, right.
I always wondered why they had them on those slopes. It looks like such bloody hard work always.
Yeah. No, it was purely to get as much sun as possible.
Fantastic. Okay. Other questions?
I just want to recommend the book. I've read the book. I sat down when I got it and read it almost cover to cover. It's just such a great read, James. And I really recommend everybody get hold of it and read it. And as you said, the banana wars, and it's just fascinating what's gone on with the history of bananas.
Oh, it is. Yeah, yeah. It's well, thank you for that, Jennifer.
Yes.
Great book.
Well, I think it would be useful for me to pass on to my teachers as well, because that could be quite interesting, especially at this school where they've got bananas to then like connect into it.
Yeah,
Sure.
exactly.
Actually, I was curious, James. I got sent the information about the book from Nikki at Melville House, but so an English publisher. I just wondered why an English publisher was there.
Ah, right. Okay, yes. So it's part of a series that Melville House do. And if you get online, you can see the whole, the range of them. There's the Future of War Crimes Commission, there's the Future of Truth, there's the Future of Fraud, the Future of Gardens, Future of Energy, Future of Travel. And they contacted me and they said, we want you to do the Future of Bananas. And I like you, Judy, I was a bit, why would you want to do that? And it was a very interesting exercise, because I've been writing scientifically for a long time, and changing my terminology so I didn't lock everybody out was to start with quite challenging, and then I started to really enjoy it. It was and the other thing is that they're short books. They're 25,000 words. And so you've got to be spot on. There's no rambling at all. You've got to really concentrate on the topic.
Fantastic. All right. Well, look, it's actually in my introduction, I didn't mention the most important thing, that the piece of information that was there is that that you're a keen gardener, and you actually had your own garden open for Open Gardens Australia. So we're very proud of the fact that you are also a keen gardener. It's lovely to have somebody who do you grow bananas?
Oh my word!
What a silly question.
In fact, one of the things I'm doing now that I've got a little bit more time, well, I thought I had a little bit more time, and I don't seem to, is I'm putting together a banana collection as well.
Oh,
So getting a whole lot of different bananas. So one of the ones, and I think, Jennifer, if you read the book, I've got a little banana in there called Golly Golly Pot Pot.
Yes.
which I think is a most wonderful name. Well, we in our collection at QT, ours is all an in vitro collection. We've got Golly Golly Pot Pot. So I said to a couple of my friends, I said, what's it like? And everyone said, we have no idea. So I've got 3 plants of Golly Golly Pot Pot, which I'm going to plant in the next in the next probably 3 months when it warms up a bit. And I got East African Highland bananas, and so quite a reasonable collection. I'm going to get some more, of course.
Fantastic.
That's wonderful. You just want to take one of those photographs, don't you, to compete with that one you already have. It's been it's been so interesting. It's been entertaining. It's whatever skills you got in writing that book, you've certainly transported them across to giving a presentation as well, because it was just enthralling. So we are so grateful to you for your time, for your knowledge, for the honour of spending this hour with us, and congratulations on the book, and we hope it sells its little socks off. So please put your hands together for the professor, and happy retirement.
Thanks, James.
Thanks, James. That was wonderful.
Thank you
very much.
Wonderful. Thanks very much. And I'm sorry about that little hiccup with the technology to start with, but I think that goes with the territory, doesn't it?
It does. Yeah.
Yes, it does. So thanks.
Okay.
We'll let everyone
Thanks,
go.
team.
We're not
Okay.
closing.